exgid, so the files will always appear to be owned by you. This isn't critical, but it's just nice. And then I have my typing function. So I take the path, whatever path gets sent into get attribute, I take my path, and if it's root, I return that it's a directory of 0755. There's 2 links. Do you remember why there's 2 links? We talked about this last time. Right. So if it's actually a dir, app dir, I meant like a function dir. It's also dir 755 too. So this could actually be combined. If it's a doc, that means the type went through, found out that I have a doc, found out that it's a valid path, found out that it's a valid function, and found out that I'm asking for a doc. So then it returns that it's a regular file, ifreg, of all read-only for everything, 0444, and it's a size 512. Like I said, I don't really care. I could use some, I could actually figure it out here and get the selected, we get the site user string and put it in. Here I say if it's an app call incomplete, so if it's an incomplete function call, I do this by checking the number of parameters. It's a directory. Same as root and this other directory. And if it's an app call, obviously it's a file. Very simple, right? All the magic is in the typing function. Otherwise, just return that. If type returns invalid, I actually have it return invalid if it's an invalid path, then it just doesn't nothing. What?
You only comparing for 4 types?
Yeah.
Yeah, you defined 5, didn't you?
Hold on, what did I define? No, if it's root, dir, what did I miss? No, I did find it. I did find it. Root, dir, doc, calling. The calling complete is the important one. And obviously you can combine these into the ones for directories or whatever. I just did this for clarity. And of course, if it's anything else, it's invalid, so then I return a problem. Does this make sense? It's a nice, concise way to do it.
Okay, so it solves the problem where it knows P1 is valid because your typing function does that?
Yeah, the typing function figures out that this path represents a valid function call,
Okay.
but it doesn't have enough parameters.
Okay.
If it were a function that wasn't even valid, like if I said /ABCDEFG / something, type would know that it's not a valid function.
Right, okay.
So read dir is also very simple. I get the path type. If it's root, then I put the 2 dots in, and then I iterate through my list of functions. I'll go over my function list a little bit later. I think I glanced over it last week. I go over my list of functions, put an entry in there for each of their functions. If it's an app dir, then I put in the two link ones, and then I put in doc. And anything else, there's no other directory that you should be able to list. Yes.
What's doc?
The documentation file. You're required to have a documentation file inside each function. Just a couple lines. You can start it all.
No, I'm sorry. I just taking that time. I'll take that time, though.
No, it's okay. Yeah, you just have to put a doc file. Right? So that's it. That's it for read dir. Open. What can you open? You can open docs, and you can actually open a valid function call.
So much more simple than what I have.
Right?
Yeah.
This is why I'm saying that categorizing into
So if
these
you have a
types
pass, you can-
makes the implementation beautiful. Same thing with read. Read is very, very simple. So I made a result string, a very big one. I did this, I set the first one to null. I get the path type, again, use my typing function. If it's app.doc, then I get doctext. And get doctext figures out which function this app is calling. And puts it into the result buffer.
So if you call Fibonacci and it sticks a bunch of stuff in the result buffer, like are the number of digits you can print out limited by the size of that buffer?
Yes.
Okay.
So you want to make that buffer big. I made it 32K just to be big enough. Ideally, in your function, you should limit it to the size of the buffer. You should have like the buffer size defined somewhere and actually limit it just in case somebody asks for something really big. That's just good programming practice. I just skipped over that.
Okay.
Same thing if it's an app call. If it's an app call, that means type already check to see if it's a valid app call. So I execute app with this app. This will actually figure out which function to call and put the results in result buffer. If it's neither of these, then return nothing. And here's the code. This is boilerplate code directly out of the MathFS example. Len is strlen result buffer. That won't be 32K. It'll just be the size of whatever is in there, whatever string is there. And this is really boilerplate code. This is just to figure out what I should pull, because sometimes you can call read with an offset. Or you can actually call read and say start from the 5th byte. But you really do want to do this.
What function is that?
Huh?
What function is that?
Read. Just like I said, this is boilerplate. It just copies the buff into the buffer that the user provides, the result buffer plus the offset, and then size. That's it. That's completely boilerplate from the HelloFS example. All you got to do is get the strlen of result buff and actually put in result buff for this. So that's completely it for the Fuse implementation.
That's not established.
Everything else is in the magic backend stuff, which is why I would like you to realize those categories that I mentioned before are really important. If you were able to classify any path into one of these categories, it becomes trivial. So let's actually look at some of these things. Oh. Let's look at actually how I define my function list. We glanced over this last time. What I did was I defined a struct function def. I have a function pointer here. All of my function implementations are of a standard format. It's they're like this, right? Return an int for success, int RC, char RC, char result. So these two are just like main and C. This is an argument count. This is an array of arguments. This is where the results go. So any function I write can look exactly like this. If I can pass any number of arguments and return any result. So I made that standardized. I have arg count defined with the function, so I can always make sure for any given function I can check how many arguments it needs. Short name and description text is my doc count. So then I define a global of these structs, the number of, in that a global array, a list or a table. The number of those entries is function count. And then I have a macro that initializes them all. There's my categories. In apps, I have my implementations, and I also have the load app function. This is what defines them. So to add another function right now, all I would have to do is add. I would have to go into here, increase the function count, implement the function, and put a def function call here, which is the number of functions, the function, number of arguments, short name, and the documentation text. And if I just added that and compiled it, I would mount my file system, and that new stuff would be there. because of the way this is implemented, abstractly. All right, so let's go look at my helpers. I tokenize my path. I pass it the path, right? I pass it a variable that I can put the token count back into by reference, and I pass it a list that is going to eventually put the token into. It string tokenizes it like we went over last time. While we have more tokens, put them in there. This is a quick and dirty allocation of a buffer for those tokens because it's a two-dimensional array. You can't just declare it statically, you have to do malloc. Malloc is memory allocate. So I say this buffer is equal to malloc, this is the number of entries, times the size of a character pointer. So that's the outside. Okay, before I go any further, do you understand why a list of strings has to be an array of pointers? Yes. Strings are pointers, right? They're just arrays, a memory array. So a string is the pointer of its first field. So a list of strings has to be an array of pointers. That's why it's char star star. Array of pointers, right? So it's an array of arrays. So for each of those, I have to actually set each of its fields to a valid pointer. So a malloc max file name, which is a constant, size of char, and then put nulls in them all. So that's a quick and dirty allocate. The allocate is the same, go through all of them and treat the individual elements and then treat the outside. If somebody doesn't get something, I can stop and explain.
Why
Because this is standard C.
are you allocating beyond
Because I need memory, whenever I tokenize the path, I need memory to put it in.
Okay.
You could have a global, but Fuse is multi-threaded.
Oh, okay.
I thought about having a global, but it really is multi-threaded, so you can't just have a global that everything is shared.
Yeah.
You actually have to allocate it as you go. Here's my typing function. So I obviously allocate a buffer for the characters. I check right away if the path is slash, I don't even type it. I just return that it's root. Here I tokenize it, and based on the tokens, I can figure out a couple things. So right here I tokenize it, and then check the token count. If it's greater than 1, greater than or equal to 1, that means I have something. So I take the first token, and I check it against my function list to see if it matches one of the functions in my list, short name. And if it is, I set valid function 1, and then break it. Then I go down and check, okay, so if token count is 1, that means there's only slash add, right? If the token count is 1 and I have this valid func is true, which means a part of my list, I return that it's an ASCII. If token count is 2, and it's a valid function, and the second token is dot, I return dot. If token count is greater than or equal to 2, and it's a valid func, and it's not a valid func call. This is something that actually checks the whole path. See if the whole path is a valid func call. Some of this is redundant. I actually simplified parts of it and didn't finish simplifying it. But anyway, it's the logic, right? If token count is greater than or equal to 2, so it's actually a call, but it's not a full valid func call, then return incomplete. Otherwise, if this is not true, then this must be true, right? So if it's greater than 2 and valid func, by the time we get here, it must be a valid func call, so then return call. Otherwise, return it back. Right? So this does everything. If it's not a valid path, it won't be valid. It won't be valid func won't be set. So if you call like /abc, valid func won't be set. None of this will return. You'll end up just returning invalid. So this tests everything too. And it's a relatively short function. and then I deallocate our token buffer. There's a lot of redundant code in mine because I was writing this while I was learning how to use Word. So this is get function index. This just for any given app name finds what its index in the table is. Is valid func call. You see what I mean redundant? I actually go and tokenize the path again for is valid func call. I really should do this all with the typing function. But anyway, I do the same thing. I just go through and see, check each thing, see if it's valid, and then if it's valid and the token count is equal to the arg count plus 1 that's in the list, obviously it'll be arg count plus 1, right, because it'll be a plus add plus y plus 3. So if add has 2 args, then the token count should be, or the number should be 3. So it's simple, right? Check to see if it's in the list. Check to see if it has the right amount of arguments. Get app name actually, again, tokenizes it. It tokenizes it and gets the first part of the path. Puts it into the buffer. My MacBook's going haywire. Looks like it's added all that stuff.
I was gonna say time to the machine, sorry.
Actually, I have 10 days to renew my Apple Care.
You can renew yours?
Yeah, if you can add Apple Care to it as well. Okay, so I only have the free year that came with it,
Oh,
so I can add the extra 2 up until 1 year.
Up until what?
I have to do it.
Because mine ends in like 2 months,
Yeah,
and then I'm just done.
you should sell it for them.
Oh yeah, definitely.
Okay, so
I can sell it before that.
so get app name. So this is a silly function.
I can sell it for like.
Which one? Convert?
This does almost the same as my tokenize function. I'm not sure why I wrote this. It does almost exactly my tokenize function. It's not really that necessary. Just converts it to an arg count and an arg vector, which is the same as the tokenize. Get document. This is what actually gets called in read. So what do? Get my app name from the path. So I get from the path, I get the app name. I get the function index from that app name. And then I stir copy directly from the function list, the function table, offset by that function index, the description. Copy it right into buffer, which is given to us by the read function. Execute app does almost the same thing. It takes the path, it tokenizes it into the argc, argv format. I think I just used 20. I hard coded them. For it could be each one could be 20 characters long, and I made 20 of them. Use convert to argv, which the tokenizer function will work fine. I get the function index of the first argument. Obviously, that's the command. And remember, we already checked for whether it's valid before. Here's how I call the function pointer. You use parentheses around star the function pointer, so function list offset by the index dot impulse. That's the function pointer. So parentheses with a star in front, and then just give it the parameters and just normal function call. That's funny syntax, right? And then I free up my variable. So this is actually where the execution happens.
So you're freeing, you're freeing your entire list.
Yeah. Because I'm done.
Yeah.
My function's done. And then I return. This buffer is what got passed in. So now it's already in the buffer that read needs. And that's it.
When does execute get called?
In read.
In read, okay.
And so MathFX is just, typetext for all this stuff. So that's my entire implementation. Is this more complicated or simpler than what you were envisioning?
Wait,